Good morning, grade 7 students. Today's lesson is weight and mass. Before listing the differences between weight and mass, let's look at this man. This is Newton. I think we all know him. He is the great mathematician and physicist in all time, and he was the first one to discover gravity, thanks to the apple. Now, let's go back to the differences between weight and mass. So mass is measured using a scale balance or a rubber balance, while weight is measured using a spring balance. The SI unit of mass is kilogram, while the SI unit of weight is in Newton. Mass doesn't vary with the place, while weight does vary from one place to another. Now, after listing the differences between weight and mass, let's start by how to measure the mass of solid and liquid. I'll be using now scale balance. So first of all, scale balance consists of two buttons, on button and tear button. I'm going to measure the weight of the empty container using the scale balance. So the mass of the empty container is 200 grams. Just keep in your mind that the empty container is a solid. It has a definite shape and it can be held by fingers. Now, I'm going to fill this empty container with liquid and then remeasure the filled container. So the mass of the filled container is 376 grams. So to calculate the mass of the liquid, in this case, I'm going to subtract the mass of the empty container from the filled container. But I can also measure the liquid directly using the tear button. There is another instrument to measure mass. It's rubber balance. But in this case, I can't measure the mass of the liquid directly. There is no tear button. I have to subtract the mass of the empty container from the mass of the filled container. So here's the difference. Scale balance allows me to measure liquid directly. Let's go to application. Number 1. Calculate the mass of the empty container in SI unit. The mass of the empty container is 200 grams, but the SI unit is kilogram. So I have to convert from gram to kilogram. All I have to do is to divide by 10 to the power 3. So the answer is 200 divided 10 to the power 3, it's 0.2 kilogram. Calculate the mass of the filled container in SI unit. So same process. We have to convert the mass from gram to kilogram. Then 376 divided by 10 to the power 3 is equal to 0.376 kilogram. Number 3. Deduce the mass of the liquid. So we have to calculate the mass of the liquid from the filled container and the empty container. Then the equation is, then we have to subtract the mass of the empty container from the mass of the filled container. So it's mass of filled container minus mass of empty container. 0.376 minus 0.2, the answer is 0.176 kilogram. Weight equal mass times gravity. Let's make it easier. So we have a pumpkin of mass 3060 grams. Let's measure the mass of this pumpkin in other place. Let's try on the moon. The mass is still 3060 grams. Let's try it on Mars. It's still 3060. And on Jupiter, also it's still the same. Let's now measure the weight of the pumpkin on Earth. It's 30 Newton. On the moon, 5 Newton. On Mars, 11.4 Newton. And on Jupiter, it's 75.9 Newton. So mass stays the same, but weight differs. Back to our lesson. Let's look at this magic triangle. This magic triangle summarizes the relationship between weight, mass, and gravity. So, how it summarizes them? Let's look at the line between mass and gravity. Suppose this line means multiply. So, we want to calculate weight. Just cover weight and you got the first relation. Weight equal mass times gravity. And now, the line below weight is divide. So, if we want to calculate mass, then just cover mass, and then you got the second equation, mass equal weight over gravity. Let's try to calculate gravity. So to calculate gravity, just hide gravity, and you got the third equation, gravity equal weight over mass. Let's apply on this rule. We have the same man standing on two different planets. The mass stays the same, but the weight will differ for sure because the gravity differs. So to calculate weight, we will use the relation weight equal mass times gravity. So weight equal mass times gravity. On Earth, it's 50 times 9.8. And on Mars, it's 50 times 3.7. Pay attention to the units. They must be in the SI unit. So weight of man on Earth is 490 Newton and on Mars is 185 Newton. Let's start by solving this application. Calculate the weight of a car on Earth knowing that its mass is 1.4 ton. So we must have the units in the SI unit. So we must convert from ton to kilogram. To convert from ton to kilogram, we must multiply by 10 to the power 3. So step 1 is 1.4 times 10 to the power 3, it's 1400 kilogram. Then the next part. All the units are in the SI unit now, we can start solving. Let's remember the magic triangle. Now, we want to calculate the weight, so we have to cover the weight to get the relation. It's weight equal mass times the gravity equal 1400 times 9.8, the gravity on Earth, equal 13,720 Newton. Just remember the SI unit of mass is kilogram and the SI unit of weight is Newton. Let's start another application. Calculate the mass of a rabbit knowing that its weight on Earth is 35 Newton. Remember, gravity on Earth is 9.8 Newton per kilogram. Our magic triangle cover mass and the answer is mass equal weight over gravity. Substitute numbers. 35 over 9.8 and the answer is 3.57 kilogram. Number 3. Calculate the weight of the same rabbit on Mercury. Gravity on Mercury is 3.7 Newton per kilogram and the mass of the rabbit is 3.57. Our magic triangle cover weight and the rule is mass times gravity. So weight equal mass times gravity. The mass is 3.57 and the gravity is 3.7. So 3.57 times 3.7 and the answer is 13.21 Newton. And now the last application. Calculate the gravity on Jupiter if the weight of this rabbit is 87 Newton. Just remember the mass of this rabbit. The mass of this rabbit is 3.57 kilogram. So we have the mass and we have the weight. We need to calculate the gravity. So our magic triangle, we cover gravity and we observe the equation. Gravity equal weight over mass. Now we substitute the values. It's 87 over 3.57 and the answer is 24.37 Newton per kilogram. Then the gravity on Jupiter is 24.37 Newton per kilogram. Hope you enjoyed this session. Thank you for attending. And of course, you will not forget to love Newton.